So hello students and friends. Uh, in this video I'm going to solve the question number 1 and 2 which were given in the specimen paper of the subject chemistry, the subject code 9701, the paper code 04 of the specimen paper of the A-level Cambridge Board chemistry exam. In my other videos, if you see the playlist, I have discussed the other questions. Now I'm going to discuss the solution of question number 1 and 2 in detail. So if you like the video, then please subscribe to my channel and give it a like and give your comments. So we start with the question number 1, which is state what is meant by partition coefficient. So for partition coefficient, this is the kind of diagram that we refer to while discussing the partition coefficient, and the partition coefficient has been defined as the ratio of the concentrations of a solute in two immiscible solvents at equilibrium. For example, in this case, ammonia has been partitioned between an aqueous phase and an organic phase, and they are in equilibrium, and the ratio of the concentrations of ammonia in the organic solvent and the aqueous solvent will be called as the partition coefficient. So hope you understood this. Now we go on to the next part. Ammonia is soluble in both water and organic solvents. An aqueous solution of ammonia is shaken with the immiscible organic solvent trichloromethane. The mixture is left to reach equilibrium. So here ammonia has been dissolved in water, and then in the separating funnel some organic solvent has been added, and it has been shaken so that part of the ammonia goes into the organic solvent, and then they reach the state of equilibrium. Then what we do is that we take a 25 centimeter cube sample from the trichloromethane layer. That means from this layer we are taking 25 centimeter cube of the sample, and when we have titrated it against the HCl, which we must have taken in the burette, and we required 13.0 centimeter cube of the hydrochloric acid whose concentration was 0.100 mole per dm cube. And in the similar way, when we took out the 10 centimeter cube sample from the aqueous layer, and it required 12.5 centimeter cube of the same hydrochloric acid, 0.100 mole per dm cube, and the endpoint was obtained at 12.5 centimeter cube of the hydrochloric acid. Now using this data, this information, we have to calculate the partition coefficient of ammonia between these two solvents. So as you know, we must know the concentration of ammonia in the organic solvent and divided by the concentration of ammonia in the aqueous medium. So the concentration of ammonia can be obtained from the value of hydrochloric acid. So we required for the aqueous layer we required 12.5 centimeter cube. So if we convert it into dm cube, we'll divide it by 1000, and the formula for concentration is N over V. The number of moles is 0.1 times 12.5, and this is converted to dm cube, and when we divide by the volume, which is 10 centimeter cube, again converted to dm cube, you get the concentration of ammonia in the aqueous layer. In the same way, we can get the concentration of ammonia in the organic layer, which is 0.1 into 13 divided by 25, this one, This 1000 anyway gets cancelled, so we get this as 0.052. So in the organic layer it is 0.052, and in the aqueous layer it is 0.125. This is the ratio, which is 0.416. You can even reverse the ratio and write it as 0.125 over 0.052, which is 2.40. Both the answers have been given are correct, and therefore either way you could write, but ideally you should write in this way, because it's between organic and water. So organic comes up and the water comes down. So this is the normal way, but the other way also has been accepted. So either of the answers will be accepted. So this is how we find out the partition coefficient. So hope you understood this. Now the next part of the question is that butylamine is also soluble in both water and organic solvents. Suggest how the numerical value of Kpc of butylamine between trichloromethane and water would compare to the value of Kpc calculated in A2, that is this part, and explain your answer. So what has been done is that this ammonia has been replaced by butylamine. Now butylamine has got more of this hydrocarbon part, C4H9. So this is non-polar, and therefore it will be more soluble in the organic solvent, because this is also organic. So this will be dissolving more in the organic solvent. That means this value would increase, therefore the value of Kpc would also increase. So this will be more soluble in the organic solvent owing to the non-polar group. So this numerator would increase, and therefore this will become greater than 0.416. That's the answer. Now butanamide is much less basic than butylamine. Explain why. So butanamide is this formula, C3H7CONH2, and the lone pair of electrons on the nitrogen is pulled away by the electronegative oxygen. Therefore this electron pair will be less available on the nitrogen in comparison to the simple butylamine, where there is no C double bond O group, and therefore this would be less basic than butylamine. So that's the answer. I hope you understood this. So now we go on to the next question. The feasibility of a chemical reaction depends on the standard Gibbs free energy change delta G. This is dependent on the standard enthalpy and entropy changes and the temperature. State and explain whether the following processes will lead to an increase or decrease in the entropy. So the first question is the reaction of magnesium with hydrochloric acid. So this is the reaction. You can see that we get hydrogen gas liberated in this, and you know that gas has got a greater entropy in comparison to solid and liquid, and therefore the entropy increases, and the reason is the formation of the hydrogen gas. The dissolving of potassium chloride in water. So when it is solid, then it is having a greater order, but when it dissolves it changes into aqueous, and therefore the entropy increases. Now when it condenses the steam to water, then water is a liquid, so from gas to liquid the entropy decreases. So that's the answer. Okay, that was easy. And now we go on to the B part, that magnesium carbonate can be decomposed on heating. This is how it decomposes. It forms magnesium oxide and carbon dioxide. The enthalpy change of this reaction is plus 117 kilojoules per mole. The positive sign indicates that it's an endothermic reaction. The entropies of the reactants and products have been given, and you have to find out the delta G for the reaction. Be reminded that delta G is delta H minus T delta S. The delta H is already given. We need to find out the delta S. The delta S is the entropy of the products minus the entropy of the reactants. The products are magnesium oxide and carbon dioxide. You can add them, subtract the entropy of the reactant, and you get the entropy change. But this entropy change is in joules, because all the values are in joules. So you should convert that into kilojoules by dividing by 1000, because this value is given in kilojoules. Making that change and we applying this formula, delta G is equal to delta H minus T delta S, we get the value of delta G as plus 64.8 kilojoules per mole. Okay, now why this reaction is feasible only at the high temperatures? As you know that this reaction is not feasible at the temperature of 298, because this delta G is having a positive sign, so this is non-spontaneous. But this reaction will become spontaneous at high temperatures, because when the temperature is high, the T delta S value would increase, and when this increases on subtraction, you will get the delta G value as a negative answer, and therefore this reaction will become feasible at the higher temperatures. So that's the answer. Hope you understood this. Then we go on to the C part. You have been given the KSP values of the various carbonates, and you have to say whether the solubility increases or decreases. As you can say that it is becoming a more negative value, that means the solubility decreases, and the reason is that the KSP value also decreases, so the solubility decreases. Write an equation to show the equilibrium for magnesium carbonate. So when magnesium carbonate solid dissolves in water, it forms Mg2 plus aqueous and carbonate ion CO3 2 minus aqueous. That's the equation. And what is observed when a few centimeter cube of sodium carbonate are added to a saturated solution of magnesium carbonate? So you only need to consider the carbonate ions, because sodium ions are not present in this equation, so you may ignore them, just consider the carbonate ions. So if you will add carbonate ions to the system, the concentration of carbonate ions would increase, and therefore it will push the equilibrium towards the left hand side, and because of that some magnesium carbonate solid would get precipitated, which is white in color. So that's the answer. To find the solubility, once a solubility product has been given using the relationship KSP is equal to S squared, that is the concentration of magnesium times the magnesium carbonate, which can be considered as S times S, which is S squared, where S is the solubility. So the solubility is the root of KSP. The KSP value has been given over here, and you just take the square root of it. You get the answer of solubility in moles per dm cube, and when you multiply it by the MR of magnesium carbonate, which is 84.3, you can add up the atomic masses. You will get the solubility in grams per dm cube, which is 0.27. Okay, and the last part of the question is that how the thermal stability of the carbonates in group 2 elements changes. So we have got magnesium carbonate and we have got calcium carbonate, and this is how we go down the group. So you can see that magnesium ion is small in size, so it has got a greater charge density, so it polarizes the carbonate ion, that means distorts its shape, and because of this distortion, this the negative ion is polarized, and the bond between the magnesium and the carbonate becomes weaker. But because the calcium ion is larger than the magnesium ion, its polarizing power is less, because its charge density is less, so it does not polarize the carbonate ion, or less polarized, which makes the bond stronger, and therefore the thermal stability increases down the group, and that's the answer. Hope you understood this, and that also brings us to the end of the question 2. So in this video I solved in full detail the question number 1 and 2 of the specimen paper given by the Cambridge International in the A-level chemistry. Hope you fully understood the solution which I gave you in this video. If you liked and understood the video, please give it a like and give your comments. Thanks a lot for watching.